So here we are looking at section 11.2, which is about the fairness criterion for the different voting methods. So we have what are called 4 fairness criteria. Number 1, so a fair election a truly fair election, you would think, would have these 4 criteria. So basically mathematicians and philosophers have decided that these criteria would constitute a fair election method. So number 1 is the majority criterion. So if a majority rank a particular candidate called X as their first choice, then candidate X should win the election. That sounds like a pretty fair thing, right? If the majority of people want X to be the winner, then X should win the election. Okay, here's another one called Condorcet's criterion. And it says, if candidate X can defeat all of his opponents in head-to-head matchups, then candidate X should win the election. So regardless of what election method you're using, if candidate X could win in head-to-head matchups against all his opponents, he should win the election. So that's a second mark of a fair election. Number 3, this one is called independence of irrelevant alternatives criterion. And it says that if candidate X wins an election, and then some non-winners, or you could say some losers, are removed from the ballot and a recount is done, then candidate X should still win the election. Okay, and finally the last one, the monotonicity criterion. If candidate X wins an election, and then in a re-election, you have some voters that change their votes, but they only change their votes in favor of candidate X. So candidate X is going to be getting more votes the second time around in the re-election. Then candidate X should also win the re-election. I mean, that seems very commonsensical, right? If you get more votes the second time, then you should still win. Okay, so there are 4 fairness criteria: majority, Condorcet's, independence of irrelevant alternatives, and the monotonicity criteria. So we had 4 voting methods, right? Plurality, board account, plurality with elimination, and pairwise comparing. And we had 4 fairness criteria: majority, Condorcet's, independence of relative alternatives, and monotonicity. So it turns out that the plurality method must always satisfy the majority criterion and the monotonicity criterion, but they do not always satisfy Condorcet's criterion or the independence of relative alternatives criterion. As for the board account method, it only ever is guaranteed to satisfy the monotonicity criterion, but not the other 3 necessarily. Not necessarily majority, not necessarily Condorcet's, or not necessarily independence of relative alternatives. As far as plurality with elimination, it's guaranteed to always satisfy the majority criterion, but not necessarily the other 3. And as far as pairwise comparison, that method, remember that's where you do head-to-head matchups, that is guaranteed to satisfy the majority fairness criterion, the Condorcet's fairness criterion, and monotonicity fairness criterion, but not necessarily independence of irrelevant alternatives. So it turns out that none of the 4 methods necessarily will satisfy independence of irrelevant alternatives. But the most fair method would be pairwise comparing, right? Pairwise comparing satisfies 3 of the 4. So after pairwise comparing, the next most fair would be plurality, right? It satisfies 2 of the 4 criterion. And the least fair methods would be either the board account or the plurality with elimination method, because those each only satisfy 1 of the 4 criteria. Okay, so we want to do some voter preference tables. We had done some already. We want to do some more. And we want to follow the instructions. So here we have a voter preference table. We have a number of ballots, 6, 5, 4, and 2, cast in a certain way. So 6 people prefer the ordering ACB for second and third place. 5 people prefer BAC in that order. 4 people prefer CBA. And 2 people prefer CAB in that order. preference. So use the plurality with elimination method to determine the winner. Okay, so we're doing plurality with elimination. So round one, we're going to look at percent for A, percent for B, and the percent that C is. Now, if anyone reaches a majority, they win. If not, then the person with the lowest percentage drops out. So let's see, how many voters do we have in total? So the total number of votes here, we got 6 plus 5 plus 4 plus 2. 6 plus 5 is 11, 11 plus 4 is 15, 15 plus 2 is 17. So we have a total of 17. So we're going to be dividing by 17 on each of these. So for A, first place, A gets here 6 votes. B's going to get 5 votes for first place. And C is going to get, let's see here, 4 plus 2 votes in first place. So it's going to be 6 votes. Now if I take 6 divided by 17, I'm going to get about, let's see, 35.3%. And 5 divided by 17, that's about 29.4%. For B, and for C, 6 out of 17, 6 divided by 17 is about 35.3%. So no one has a majority, so one of them has to drop out. B is going to be eliminated, so B here is eliminated because it has the least percentage, the smallest percentage. B is eliminated. That means we have to have a round 2. So in round 2, we're basically eliminating B, right? So we eliminate B. So we're looking at A versus C. So let's look at the percent for A and the percent for B. Still out of 17 votes in total. So A is going to get, let's see, 6 here and 5 here. That's going to be 11. And okay, so we're doing A versus C. My bad, B dropped out, so we're doing A versus C. So percent for C, we got to take 4 and 2. 4 and 2 is going to be 6. 6 out of 17 for C. So 11 out of 17 as a percentage would be about 64.7%. And 6 out of 17, that's 35.3%. And it looks like someone made a majority right. A makes a majority, so A actually wins. Because A breaks majority status. So A wins using plurality with elimination. Okay, so number 2 here, construct a new voting preference table. So C and A are going to be swapped in the 4th column. The 4th column. Then use plurality with elimination again, okay? Oh, crap. Okay, where did it go? Here it is. It's acting like garbage. Okay, so we're going to take this same table, but we're going to go in the, does it say 4th column? Yeah, it says the 4th column. So in the fourth column, we're going to swap the A and the C. So we're going to swap these right here in the fourth column. So we'll swap those and we'll do plurality with elimination. So let me write down that table. I'm going to swap A and C in the fourth column. So here we go. Here's my new table. So I have here preference, have number of votes, number of votes was 6, 5, 4, and 2. We had first, second, and third place. We had what? A, C, B, B, A, C, C, B, A. And the fourth column is what's changing. We're swapping the C and the A. So B is going to be here. Now previously we had C in the first position and A in the second position, but we're going to have A now in the first and C now in the second. So that's the new positioning of A and C. C and A. All right. So we want to do plurality with elimination. Let's do a round 1. We want the percent for A, B, and C. See if we can get a majority. If not, then someone gets dropped out with the lowest percentage, and we go into a second round. These are going to be out of 17 votes, remember, total. So for A in first place, we have 6 here and 2 here. That's 8. All right, for B, we got, it looks like 5 here. And for C, it looks like we have 4 here. So 8 out of 17 is 47.1%. That's not a majority. Then 5 out of 17 is 29.4%, roughly. And 4 out of 17 is about 23.5%. So nobody wins, but someone is dropping out, right? We have a minority, the smallest. C is eliminated. Now it's time to do a round 2. Hopefully we get a winner on round 2. We got percent for A, percent for B. These are out of 17. So let's drop out C. So let's cross out C here, 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 and here. So percent for A. So A will be in first place 6 times here and 2 times here. That's a total of 8. 8. And what are we doing? B. B is going to be in first place 5 times here and 4 times here. That's 9. So 8 out of 17 is 47.1%. And 9 out of 17 is 52.9%. So we have a clear winner, a majority, right? The majority wins. B wins. More than 50% is a majority. So notice when we did it the first time, A won. The second time, B won. But A actually got more votes. So remember the first time, in that fourth column, when you look in that fourth column, C was winning over A in that fourth column. And then we gave A more votes, right? It got 2 more votes. But still, A did not win the second time. That's kind of crazy, isn't it? You get more votes. Right, you got votes switched in your favor, but you don't win. Well, that can happen here when you're doing plurality with elimination. That just illustrates that point. So this is number 3, which fairness criterion is violated here. Go back and look at the fairness criterion. It's going to be this one called the monotonicity, right? If candidate X wins an election, and then in a re-election, all voters who change their votes only change their votes to favor X. So let's say X gets more votes the second time around, then candidate X should win the re-election. This is precisely what's happening, right? Candidate A got more votes the second time around, but did not win. It should have won, right? You would think he would have won if he got more votes, but he did not. So because he did not win the second time around, the re-election after getting more votes, this type of election method is violating the monotonicity criterion. So the monotonicity criterion is violated.